Could boosting the brain's cleaning system be the key to new migraine relief? For the approximately 14% of the global population living with migraines, relief is often elusive. While modern medicine has made strides, a significant gap remains. Roughly 1/3 of sufferers do not respond to current treatments, leaving them trapped in debilitating cycles of pain that can last for days. However, new research suggests that the solution might not lie in just blocking pain signals, but in enhancing the brain's own ability to clean itself. The problem? When standard treatments fail, current migraine therapies, such as triptans, primarily work by reducing inflammation and lowering levels of calcitonin gene-related peptide, CGRP, a neurotransmitter known to drive migraine attacks. Despite these advancements, many patients still experience intense symptoms, including throbbing or pressure in the jaw, cheeks, forehead, or behind the eyes. Allodynia, a condition where even light touch such as brushing one's hair becomes excruciatingly painful. Because many patients remain unresponsive to CGRP-targeted drugs, there is an urgent medical need for alternative mechanisms to manage the condition. The breakthrough, targeting the glymphatic system, the recent study, presented by Adriana Della Pietra at the University of Iowa, focuses on the glymphatic system, the brain's internal waste disposal mechanism. The research team investigated a drug called prazosin, which is already widely used and approved to treat high blood pressure. Through a series of experiments, they discovered a potential secondary benefit: waste clearance. In mice, CGRP, the migraine driver, appears to impair the glymphatic system, preventing the brain from efficiently flushing out metabolic waste and pain-signaling molecules. The prazosin effect. When mice were given prazosin, the drug acted as a catalyst, boosting the flow of waste fluid through the glymphatic system. Pain reduction. In testing, mice treated with prazosin were able to tolerate much thicker physical stimuli on their foreheads without flinching compared to the control group. Essentially, the drug helped wash away the chemical drivers of pain, allowing the mice to behave as if they had not undergone a migraine trigger. Why this matters for future medicine? This research is particularly promising because of the repurposing potential of the drug. Because prazosin is already an established medication for hypertension, its safety profile is well documented. This could significantly shorten the timeline for clinical trials and potential human application. If the findings translate from mice to humans, it would represent a paradigm shift in neurology, moving from merely suppressing pain signals to actively clearing the chemical triggers that cause them. If it works in humans, that would be fantastic, notes Valentina Mosienko of the University of Bristol. The drug is already in use, so we know it's safe. Conclusion: by leveraging an existing blood pressure medication to enhance the brain's natural waste clearance system, researchers may have found a way to bypass the limitations of current migraine therapies. If successful in human trials, this approach could provide a vital lifeline for the millions of sufferers for whom traditional drugs have failed.